Hello, all attendees. I'm Siddhant from Edureka, and I welcome all of you to today's learning journey where I'll walk you through the complete IoT technology right from scratch. So, if you've been looking to catch up on this rapidly emerging technology, let me tell you that you're already at the right place. We'll, in fact, be implementing everything we learn through an IoT demo. But before I begin, though, let me quickly course you all through the flow of topics that we'll be ensuring for the best understanding of this technology and its real time relevance. So, to start things off, we'll understand the vision of IoT, which mainly speaks of a connected world. From here, we'll move on to the importance of things in IoT and then go on to meet the layers that are integral to the IoT technology stack. Next, we see how all of them work together in an IoT ecosystem to nurture ambient intelligence in physical objects. And once we're through with the basics, we'll be getting hands-on in an IoT project, after which I'll be concluding with the prospects and scopes of IoT as a technology that could change the very face of digital accessibility. Now, with the agenda in order, I'd also like to encourage all of you to interrupt me at any point for even the silliest of your queries. So without putting it off any further, let us start today's tutorial on this technology of tomorrow. Now this is where we begin, with a connected world. In the IoT frame of reference, it basically means a world of networked objects connecting through a system that provides them with human-like consciousness. Now that is the simplest perception to what Internet of Things as a technology thrives to achieve, and to do so, it combines a plethora of diverse technologies. Now, as you must already know, IoT is the abbreviated form for Internet of Things. So the very name of this technology comes from two of the most important aspects of its functioning. First comes the Internet, which might not really refer to the existing World Wide Web, but rather to just a wide network that could span all over the globe and over which all physical objects could connect to communicate with the various other tools and technologies that this network is laden with. These physical objects represent the things in IoT and basically refer to any item embedded with electronics, software, and network connectivity. These could be the day-to-day devices that you use, or the vehicles you drive, or buildings, or even entire cities in the times to come. Okay, so I can see that somebody already has a question. So Pulkit here says that he could not grasp the reference that I made to the World Wide Web earlier and wants me to re-explain. Well, of course, I'd be happy to do so. Now, the internet infrastructure in use today might resemble the IoT internet network in many ways, but it has far too many flaws and loopholes to act as a backbone network to such an advanced technology. So I essentially meant that the aggregation of a superior worldwide network is being integrated to support this futuristic technology. And we'll be studying all about it further in our session today. So be assured that you'll be able to understand why the World Wide Web is just not cut out for this role in IoT. So moving on, understanding the IoT technology will be a lot easier if we analyze how our world has been getting more and more connected with time. For starters, we now have smart wearable tech that allows us to digitally track our health and fitness, or a smart car with features to stream online content and check emails, or a smart security solution enabling the digital locking of doorways and exits, or a smart lighting feature in a home automation system, or even our smartphones that bring the entire world to the tip of our fingers. Let us now visualize a world where everything was linked to each other, even us. Yes, I'm talking about a futuristic utopia that lets the digital world meet our real world, unlocking limitless possibilities to enhance a user's experience. Now imagine, what if every vehicle, home appliance, your heating or cooling systems, your light switches, and even the tiniest devices that you could either use or own was connected to the internet and linked to your personal account? Now, wouldn't that be something? Connecting, interacting, and communicating spontaneously with one another, along with storing, analyzing, and computing our data for us with better accuracy. A connected world like this could enable the improvement of living standard and service qualities, catapulting human convenience to an entirely new level. Now, me personally, I feel truly thrilled by the idea of a world full of network things. So these connected devices in today's world are popularly called smart devices. And if the entire world offered a common platform for all physical objects to become smart and interoperate, we could be making the entire world smart. Now, let me assure you that with the advent of IoT, such concepts are not just stretching the truth anymore. Like say in the case of modern cars, the smartest cars today already have hundreds of sensors and multiple computing units connected over an internal network featuring intelligence for vehicle-to-vehicle communication, identifying points of malfunction, analyzing traffic or the weather around us, and even sensing obstacles or bumps along the road. And I remember reading in an earlier research by the Gartner Ring that this is just one example of the 6.4 billion connected things that are already in use worldwide. Now, while converting physical objects into smart IoT-enabled things and embedding smart systems all over the globe might seem like all there is to do, but it is actually only the first step in achieving an IoT ecosystem. Now, with so many smart devices being used at all levels and sectors across the planet, it is about time they were geared to their full potentials by harnessing better network technologies and software infrastructures around them to establish more connectivity and house advanced tools for analytics and computing over that network itself. But what is more important to the Internet of Things is that all of this is done in a minimalistic and cost-effective way to guarantee accuracy and real-time responses. Therefore, based on the logical idea and vision of IoT, we can sum it as the digital relationship between us and our devices to ensure personalized access over all electronics and applications that we own, irrespective of our locations. Now that brings us to our second topic, the things in IoT. Mostly everything around us has the capability to become the things of IoT. All that would be required is to shape them into devices that could mount the proper combinations of electronic components, operating software, and modes of connectivity. Now, such combinations are required to ensure the transmission of collected data and the reception of insights or instructions that are produced based on them. Hence, the quality and smartness of solutions offered by these systems must largely depend on how accurate these input data are and how efficiently the output instructions are supplied or carried out. Therefore, these smart devices play an important role of determining the outcome of any smart system, all because accurate inputs and relevant outputs will make the artificial intelligence possible in physical objects. So let us understand the basic configuration of any IoT enabled thing. It essentially has transmitters, receivers, and device software for its interconnection upon networks, and transducers like sensors or actuators to collect real-time information or perform real-time operations. So apart from enabling connectivity, the things in IoT supply input or carry output for any smart system. Let us now move on to the IoT technology stack and understand how it broadly categorizes the many technologies involved into big bundles. Now, these big bundles are called layers in the IoT stack of technologies. Now, with its diverse uses and sheer size, the number of layers in the stack of technologies might add up with time, but there are three integral layers that are fundamental to every IoT ecosystem to operate on: the IoT device layer, the IoT gateway layer, and the IoT platform layer. Now, we've already talked about the device layer, which is mainly the things of IoT. This is where the IoT ecosystem begins by interacting with the physical world and collecting required environmental parameters. It consists of smart devices integrating transducers and other prerequisites for device connectivity and operation. So the gateway layer is where all the networks for device connectivity is aggregated for the devices to interconnect and transmit collected data for processing and intercommunication. It is truly the bridge upon which the data flows to other layers, but that is just one of its many functions. This layer also houses numerous technologies to pre-process the collected data and make them more relevant for the next layers to perform faster operations on it. In fact, to ensure that the outcomes and operations stay real-time in the Internet of Things, even these gateways have been known to process and provide real-time intelligence solutions. The pre-analysis and pre-processing in the gateway has been gaining tremendous popularity under the names of fog computing and edge computing. The ability of these smart and intelligent gateways to perform majority of the operations just at the edge of the gateway before it finally enters the next layer has literally put the innovations and advances of digital world on steroids. Now the IoT platform is where everything connects in its true sense. It is the worldwide network that IoT intends to integrate to allow all its devices, networks, clouds, applications, analytic tools, computing units, and other necessary software services and APIs to interoperate and centrally process the required values to produce real-time results. It houses myriad technologies needed for storage, analysis, and computing of valuable real-time information. And since the output signals generated in this layer are again sent back to the device layer for execution, the IoT platform serves as a middleware between inputs and outputs of any IoT ecosystem. As we are now familiar with the integral layers of the IoT technology and their individual functionalities, it should now be easy for us to visualize an IoT ecosystem where these integral layers cooperate to enable and fuel countless smart systems and applications. But what is more important to understand is that an ideal IoT ecosystem focuses on combining just the right kind of technologies in the most accurate, secure, and cost-effective way. The more minimal the system, the more promising its product would be in delivering smart solutions. So an IoT ecosystem could enable everyone to control all parts of their digital life. It could power the entire world by providing enriched real-time information and smart solutions based on them. So if you can see below, there's a simple diagram showing the three layers working together. First comes the device layer that senses any environmental parameters, which it sends to the gateway to the platform. The gateway pre-processes the data for smarter inputs. At times of real-time emergencies, the edge has been known to return valuable information as outcomes of a smart system without even depending on the platform to process data. So the collected data travels through the gateway and enters the platform through the edge. So the platform is where all the smart analysis, the intelligent computing and storage is done for collected data, and an output stream is returned to the device layer where the devices respond smartly based on these output streams that enable intelligent behavior in those devices. Now let me tell you the key features that an ideal IoT ecosystem will require in today's world. First of all, it will need to enable the platform to blend in with the applications that are used by the devices and gateways. It then will need to provide elastic scalability across any number of endpoints that a client may require. It should also ensure end-to-end data flow encryption and integrate high security networks and private clouds for sensitive data. And finally, it should offer heavy-duty server clusters with maximized performance for proper load balancing. So that brings us to the problem statement that we'll be solving in our demo today. I've in fact quoted a problem that had been troubling me for a while. So that is me looking troubled and lost in thoughts over there. I am an avid fan of TV shows and an absolute movie buff. But with the days of torrent coming to a close and the recent dominance of paid subscriptions and premium viewership, my life has been faltering between making my ends meet and keeping up with my passion. So that has left me wondering, is there any way I could work around this, like with torrents? In fact, there should be some way to access all these data that these streaming companies leverage. Where do these streaming companies even get their data from in the first place? Well, you won't believe how easy the solution to such a problem is with the Internet of Things. You must understand that IoT intends to be accessible to even a layman for implementing their own solutions. Having said that, let me also tell you that IoT can enable you to make the best of the entertainment sector among countless other sectors that it is capable of benefiting. So if you remember, IoT is supposed to facilitate all aspects of life in the most cost-effective way possible. And it is supposed to do so while promoting unlimited digital access for human convenience. And luckily for us, streaming free media amounts to a huge factor in digital convenience. Hence, IoT brings you the option of implementing inexpensive solutions to such important aspects of the digital world. And if you're wondering how you could do it, well, you could do it just the way Amazon or Tata Sky does it, with the only difference being that instead of depending on their media servers, you could actually build one yourself and stream all you like by connecting to the right access points. And with IoT uniting the entire world for the rich and poor alike, applications are now being specially tailored to enable anyone to host a media server and use it to connect to the right add-ons and stream all they like. And this IoT project is just one of the many countless possibilities that showcases the power of IoT to provide cost-effective solutions. Alright, so that brings us to our demo. In fact, you'll be surprised to see how easy IoT has made the solution for our problem to be. So before we attempt this demo, there are two things that you should definitely know. First is what a web server is, and second, you should know what a Raspberry Pi is. So a web server is traditionally a machine that could also be a software allowing that machine to analyze user requests and return the file corresponding to that request. And if you're wondering what a Raspberry Pi is, well, its makers define it best as a credit card sized computer. So this is a Raspberry Pi 3. Now I'd recommend using a Raspberry Pi 3 to support more users as it comes with a better RAM of 1 GB. So we'll be building a media center upon this Raspberry Pi. Now, if you're still wondering why use the Raspberry Pi as a web server rather than using the service providers specialized in web hosting, well, here's why. From an economic point of view, you should know that web hosting services are not free, that you must pay every month or every year. But unlike them, the Raspberry Pi just needs an internet connection. Plus, by choosing a Raspberry Pi, you have the possibility to modify your services just the way you want, which is generally not the case with specialized hosts that sell shared hosting with low configuration capacity. So with the Pi as a web server, you could change the size of your disk or the hosting of your database and many such features. And also, the Raspberry Pi can be connected to your TV and it will share the TV's power source without requiring an external source. It can then replace your setup box or your Fire Stick and you can stream all and any media just for free. So doing this is pretty simple. And I have a SSH client here, which is the VNC viewer, which I'll use to access the visual interface of the Raspberry Pi. You can also connect a monitor. You'll be, as it is, connecting this to your TV or any visual interface for that matter, your smartphone, your tablets, your personal computers, your laptops. It can actually enable anything as a digital home entertainment system. Now after the Pi has started, we'll be opening a terminal session. Now once we have the terminal window open, we'll make sure that the Raspberry Pi is updated, which is actually a prerequisite to any project that you do on a Raspberry Pi. So we can do that with simple commands: sudo apt-get update. So once our update is done, let us proceed with installing the media center on our Raspberry Pi. We can do that by sudo apt-get install Kodi. So Kodi is the name of our media center. Now it is loading my installation, and finally my installation is done, and I have installed the latest version of Kodi on my Raspberry Pi. Now if you're wondering how to run Kodi, it's pretty easy actually. You can only type Kodi and press enter. So that will start our media center for us, which is Kodi, and it looks something like this. So there are a lot of features on it. You can see there's a power button on the top with some settings and a search button too. Then there are add-ons which you can configure to add any third-party streaming provider to your home entertainment system. For example, I have a few here like YouTube, there's TED Talks, there's Dailymotion, there's CNN. Similarly, there's also options to watch your pictures or save your favorites, say your favorite TV show or a movie. You can also install your weather updates on it. You also have add-ons to play your music. You can connect your Apple Music or any such third-party music add-ons to it. So that's it. It's as easy as this. All you have to do is connect your Pi to a TV after installing Kodi in it. And once you've done that, your TV is officially a home entertainment system now. So go on, replace your Fire Sticks, replace your setup box, and stream all you want. Now that we saw how an inexpensive solution could be availed with the help of IoT, let us move on to the future and scopes of IoT. Now, the Internet of Things is ultimately bound to affect almost every aspect of daily life. In fact, I'll encourage you to figure out where IoT will not be. But the IoT's underlying challenge, however, is that there are no clear and agreed upon architectures for building connected systems. Like, say, our light switches may have one level of data security encryption, while our TV remote control will have another. Also, the wireless protocols will differ. Now, the bridges to connect all these options will increase, no doubt, and even if independent systems become extremely secure, we'll still have to aggregate its diverse standards, and the resulting chain will only be as strong as the weakest link. And by creating new procedures, standards, and best practices, we might be able to bring order to the disorder that IoT generates. Undoubtedly, Internet of Things will influence everything from robots and retail to buildings and bankings. And to leverage the power of IoT responsibly and profitably, everybody should be able to develop and implement their own IoT technologies, solutions, and applications, ultimately harnessing its power for a smarter future to meet every specific need. The hurdles for IoT could be lessened by half if there existed only one platform for all IoT-enabled smart systems. But that is easier said than done, with over 400 existing platforms that are racing to overtake each other in terms of functionalities and features. And unlike the internet that we have been exploiting, IoT will need a far more secure network of software infrastructures to make Internet of Things a singular unit of feasible smart systems. Plus, the high data generation rates of such systems will require more intelligent methods for analysis and pattern identification in real time. There will also be a need for faster processors with guaranteed real-time response and low-power wide area networks to provide better data rates with nationwide coverage. So that brings us to the end of our session. Well, happy learning. Thank you and cheers.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!